Next, we're going to take a look at some oxidation reactions. So for oxidations, you'll often see the oxidation abbreviated as an O in brackets. And in the simplest terms, this is the opposite of a reduction. So that means we're decreasing in the number of CH bonds and or increasing the number of CO bonds. I've listed several different oxidizing reagents for you here. You will notice that they are in two categories labeled with two different colors. The first two, PCC and desmartin periodinane, these are considered mild oxidizing agents. While the ones in red, these are all chromium based. There is chromium trioxide and acid. This is known as a Jones oxidation. You have sodium dichromate and sulfuric acid, and then chromic acid. Now, the sodium dichromate and sulfuric acid, if you actually mix those together, they give you chromic acid. So just depending on how the reaction may be written, you could see any of these reagents to all reflect a harsh oxidation. When we talk about the reactions, we're going to see the difference in mild oxidations versus harsh oxidations. So first, let's take a look at oxidizing a primary alcohol. And you'll see that I've used two different reagents here, and we'll look at each individually. The first is PCC. So effectively, what's happening in this first oxidation step is that there's a hydrogen on the carbon that's next to the OH. So what's happening is this H and this H are lost, effectively as H2. Now, it's not actually hydrogen gas eliminating, but you're effectively losing the two hydrogen across that bond. So we end up with an aldehyde product. So this is what you get if you use one of the mild oxidizing agents with a primary alcohol. Now, if we go to a harsh oxidizing agent, let's see what happens. I'm going to go ahead and draw in both hydrogen on this carbon. So in the first step, it's the same thing as the PCC, where you lose the two hydrogen and kind of lose that as H2. So we're left again with the aldehyde, but with the harsh reagent, it doesn't stop at the aldehyde. So what will then happen is this hydrogen that's bonded to the carbonyl carbon, this will become an OH. So the product is now a carboxylic acid. And while this step is different than the first, so the first you lost two hydrogen, in this step you only lost one, it's still an oxidation step because what are we doing? We're decreasing the number of carbon-hydrogen bonds. We had one, now we have none. We're increasing the number of carbon-oxygen bonds. We had two in the double bond. Now we have 1, 2, 3. So primary alcohols, you're going to see a big difference in whether you use a mild oxidizing agent or a harsh oxidizing agent. Next, let's look at the oxidation of secondary alcohols. With secondary alcohols, we have one hydrogen on the carbon bearing the OH. So there's a hydrogen here. So we can lose this H and this H across the bond. And when we draw the product, we're going to get a double bond O there. So Here I just used a generic O for oxidation, meaning it can be any of the oxidation reagents. It doesn't matter if it's mild or harsh, you get the same product. Why is that? Well, in the case of secondary alcohols, we get a ketone product, and there's no hydrogen attached to the carbonyl to further oxidize to an OH. So there's no further oxidation. Next, we have a tertiary alcohol. Again, we can subject this to any of the oxidizing agents. But now if we look at the carbon that has the OH attached, you'll see that there's no hydrogen on that carbon. So there's no hydrogen to be lost between the carbon and the oxygen. You can't form a double bond O here because that would give too many bonds to the carbon. So tertiary alcohols, no reaction. Finally, let's take a look at aldehydes. If you take an aldehyde and subject that to one of the mild oxidants, think about what's going to happen. Nothing. Why is that? Well, we already know that if you take an alcohol and subject it to one of our mild oxidants like PCC, that's going to get oxidized to the aldehyde and no further. It stops there. So clearly this aldehyde can exist in a solution of PCC with no further reaction. So if you take an aldehyde, subject it to a mild oxidant, no reaction. But if we switch to a harsh oxidant, the aldehyde is an intermediate along the pathway of oxidation of a primary alcohol. And the aldehyde gets further oxidized to a carboxylic acid. So that's going to be the same thing here. This hydrogen will get oxidized to an OH. And here's your final product, the carboxylic acid. For this course, you're not going to be required to know the mechanism for any of these oxidation reactions.